So good morning, this is VU2HMY, Dr. Rajasekhar, basically from Nellore. Today, 14th December 2022, I just came to the shack of VU2JXL, VU2JXL, OM Kishore. So we both today wants to modify the SAILOR amplifier, SAILOR T2130. It's a basically marine amplifier, HF amplifier with 6 band pass filters. So we want to modify it to use it along with any equipment, any HF equipment. The amplifier is capable of taking 1 milliwatt, that is 0 dBm input, and puts out 250 watt, almost 50 dB gain. It's a wonderful amplifier, very tough amplifier, but it requires a few steps to modify. Basically, this amplifier is made along with SAILOR transceiver. So now we are using other transceivers like YASU, ICOM, so it need to be modified. The basic thing, we will try to feed 5 to 20 watt from any transceiver, so we have to incorporate alternators like 3 dB, 10 dB or 30 dB or even 43 dB to make the input 20 watt to get the 1 milliwatt 0 dBm output. And also we are discarding the unwanted stages like DC-DC converter and microprocessor PCB, as well as the connector board. All the 3 boards we will discard from the main unit, and we will cut the almost 6 inches of the front portion to make the amplifier a bit compact. So let us start into the work. Here we are removing the chassis. The chassis is lengthier, so we will cut the chassis up to this length. We will cut this chassis and discard this portion. We are going to discard this connector board as well as the microprocessor board. So microprocessor board is being not used here because to run the microprocessor board we need a SAILOR transceiver. Here we are using non-SAILOR transceivers. So we are removing this microprocessor board and also this connection board. Then here, this is a DC-DC converter board. This DC-DC converter board also we are removing. Here we have removed this microprocessor board, DC-DC converter board, and also this connector board. So now the amplifier has become a less weight. So we have removed this DC-DC converter. Here the microprocessor board. And we are going to cut this chassis to this we are going to cut the chassis up to here. So now you can see on the chassis low pass filter board is remained, number 1. Number 2, the amplifier board is there. Only 2 boards are there right now on the chassis. Next we will incorporate the control board which we made here. This is the control board we have just homebrewed for our purpose. Here we have taken a L bracket and fixed antenna connector, a connector for transceiver, 6 band switch, manual and auto, PTT switch. So here we have made a control board with alternator. Now it's a 30 dB alternator. We are going to fix 10 dB alternator and also 3 dB alternator to give 20 watt to the amplifier. And this is the control circuit. We feed 15 volts from the outside, and this is the car circuit. The RF input from the transceiver is being fed to the amplifier via attenuators. The amplifier input is fed to the carrier operated relay. The two diode will sense, develop DC voltage and actuate the relay with some 5 to 10 seconds delay by using a capacitor. This is the car circuit we are going to incorporate here. Now we have placed the DC distribution PCB here. It's a small glass epoxy PCB placed here to distribute the DC. This section is coming from the power supply 24 volt 30 amperes. So it is being fed here. It is connected by means of 3 screws to the chassis. So this DC negative will be grounded. Then the positive 24 volts given to this section of this PCB, and 24 volts positive will go to these two orange wires to this connector to this final amplifier. Then these two orange wires goes to the driver amplifier. This orange wire, single wire, goes to the pre-driver stages. And you will see two more wires here. The brown wire is 15 positive 15 volts. The 24 volts is taken to this LM7815 regulator, 3 terminal fixed regulator. The developed 15 volts will be given to this brown wire to this pre-driver section for control, and this green wire is called amplifier on and off. This wire is being taken to the relay circuit of the control relay circuit to get biasing when transmitting. This is all about power supply feeding to the amplifier.